A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. If your automation breaks at 2 in the morning because a webhook endpoint got overwhelmed by a spike in traffic, you aren't scaling. You're just adding more failure points to a system that's already gasping for air.
That is a brutal way to start, Corn, but you are right on the money. When we move from those early days of local automation, running a few tasks on a single instance of N8N or a basic script, to building actual production-grade business solutions, that ingress layer becomes the ultimate bottleneck.
It really does. Today's prompt from Daniel is about exactly that transition. He's pushing us to look at how we decouple workflow logic from the ingress itself, specifically using tools like Kong to manage webhooks and mailhooks. And by the way, today's episode is powered by Google Gemini 3 Flash.
Herman Poppleberry here, ready to nerd out on API gateways. Daniel's point about webhook sprawl is something I've seen kill so many promising projects. You start with one webhook for Stripe, another for GitHub, one for your CRM, and before you know it, you have 50 different endpoints, all with different security standards and no central way to manage them.
It's like having a house where every single window is a front door, and you have to remember which key goes to which window, and half of them don't even have locks. It's a mess. So, Herman, for those who are used to just clicking Create Webhook in their automation tool and calling it a day, what is the core challenge here? Why is this manual sprawl so unsustainable?
The challenge is threefold: management overhead, security fragmentation, and logic entanglement. On the management side, if you have 100 unique webhooks, rotating a secret or updating a URL becomes a manual nightmare. Imagine a scenario where you have 20 different workflows all triggered by Shopify. If Shopify updates their security requirements, say they change their signature header name or their hashing algorithm, you're logging into 20 different nodes to update headers. With a gateway, you update it once at the entry point.
And the security fragmentation? That sounds like the part that really bites you when you try to change things later.
Precisely. Most basic automation tools aren't built to handle enterprise-grade authentication like OpenID Connect, JSON Web Tokens, or Mutual TLS at the edge. They might have a basic header check, but that's it. If you're a fintech company, a simple header check isn't going to pass a security audit. You need real validation before that data even enters your internal network. Think about a SOC 2 audit. The auditor isn't going to like seeing authentication logic scattered across 50 different low-code workflows. They want to see a single, hardened gatekeeper.
That makes total sense. If the security is baked into the workflow is doing two jobs at once, policing the border and processing the cargo. But what happens when the police officer part fails?
Then the cargo part gets hijacked. If your workflow node has a bug in its header checking logic, or if the underlying library has a vulnerability, your entire business logic is exposed. By moving that to Kong, you're using a tool that is battle-tested by some of the biggest tech companies in the world specifically for that one job.
And the logic entanglement. I feel like that's the silent killer. It's the technical debt that accumulates while you're busy building.
It really is. In a standard setup, the webhook URL is tied directly to a specific workflow. If you want to change the logic of that workflow, or move it to a different server, or split it into two, you often have to go back to the source system, like Salesforce or Shopify, and update the URL there. That is risky. If you have 100 different external partners sending you data, you can't just ask them all to update their endpoints because you decided to switch from ADN to a custom Python microservice. Decoupling means the source system talks to a gateway like Kong, and Kong decides where that data goes. The source system never needs to know that you redesigned your entire backend.
So Kong is essentially the Nginx for automation triggers. It sits out front, checks IDs, handles the crowd, and then sends people to the right room.
That is a great way to put it. Kong is an open source API gateway that, as of last year, was handling over 15 billion requests daily across thousands of companies. It's built on top of Nginx and Lua, and it is designed to handle high concurrency traffic with incredibly low latency. When we talk about using it for webhooks, we're talking about moving the ingress concerns, authentication, rate limiting, and routing, away from the execution layer where the actual business logic lives.
I love the idea of offloading the check API key step. I've seen 18 workflows where the first 5 nodes are just verifying headers and checking if the requester is authorized. It feels like a waste of compute cycles on the automation server.
It is a massive waste. Think about the resources. If a malicious actor decides to spam your webhook with 10,000 bunk requests, and your automation server has to spin up a process for every single one just to realize they're unauthorized, your server is going to crawl to a halt. You're paying for CPU and RAM to process garbage. Kong stops those requests at the door. If the JWT isn't valid, the request never even touches your automation engine. Your workers stay focused on actual work.
You mentioned latency earlier. If I'm adding a whole gateway layer between Stripe and my automation, am I going to see a massive slowdown? Or is this one of those things where the trade-off is worth it?
The latency hit is usually negligible. We're talking 5 to 10 milliseconds in a well-configured Kong environment. In the world of webhooks, where the source system usually doesn't even wait for a response beyond a 200 OK, 10 milliseconds is invisible. But what you gain is immense. You get things like the standard webhooks plugin in Kong. This implements the actual standard webhook specification, meaning you get consistent signature verification across every single hook coming in.
That sounds like a dream for anyone who has spent 4 hours trying to figure out why a Shopify signature won't validate because of a trailing newline character. But how does that work in practice? Does Kong have a specific plugin for every provider?
Not necessarily every provider, but it has generic HMAC and JWT plugins that can be configured for almost anything. For the standard webhook spec, it's a unified way of handling those signatures. So instead of you writing a custom JavaScript node in 8n to calculate a CA-SHA-256 hash and compare it to a header, Kong does it at the C level in Nginx. It's faster, safer, and you don't have to maintain the code.
Let's look at a real-world scenario. Say you're a retail company, and you have 500 different types of Stripe events coming in. How does Kong handle that without creating 500 separate configurations?
This is where Kong's routing and plugin architecture shine. You can set up a single entry point in Kong and use plugins to inspect the payload. For example, you could have Kong look at the event type in the Stripe JSON body like invoice.paid versus Thai customer subscription.deleted and route it to different internal services or workflows based on that. You can also use Kong's rate limiting plugin to ensure that a sudden burst of invoice created events doesn't overwhelm your CRM sync.
Wait, can Kong actually look inside the JSON body to make routing decisions? Isn't that expensive?
It can using the request transformer or specialized Lua scripts. While looking at the body is slightly more resource intensive than looking at headers, Kong is still orders of magnitude more efficient at it than an automation platform. If you're worried about performance, you can have the source system send a specific header, but even if you can't control the source, Kong handles body inspection gracefully.
But what about the complexity of the routing logic? If I have a complex set of rules, like if the customer is in Europe and the amount is over 1,000, send to workflow A, otherwise send to workflow B, is that something you'd really want to put in your gateway?
That's where the separation of concerns gets interesting. Usually, I'd argue that deep business logic, like checking a customer's spend threshold, should stay in the workflow. However, structural, routing like directing traffic based on geographic origin or the specific API version being used is perfect for the gateway. Kong can look at the Eats CloudFront viewer country header, for instance, and route to a European instance of your automation tool to ensure GDPR compliance for data residency. That's a massive win before the data even hits your logic layer.
I can see the security benefit clearly, but I'm curious about the mailhook side of things Daniel mentioned. Email to workflow is notoriously messy because email is, well, unstructured and insecure by nature. How does a gateway help there?
Mailhooks are a great candidate for this architecture. Usually, you're using a service like SendGrid or Postmark to turn an email into a webhook. Kong can sit in front of that receiving endpoint. It can handle the HMAC signature from the email provider to ensure the email actually came from them and wasn't spoofed. Then, it can use a request transformation plugin to clean up the data before it hits your workflow.
So it's essentially pre-processing the data. It's the prep cook in the kitchen, chopping the onions so the chef can just start cooking. But what if the onion is a massive 20 MB attachment? How does Kong handle heavy payloads?
That's a great question. Kong has a request size limiting plugin. You can set a hard cap at the gateway. If someone tries to bomb your mail hook with a 100 MB file, Kong rejects it immediately. Your automation server never even sees the bytes. This prevents denial of wallet attacks where an attacker runs up your cloud bill by sending massive amounts of data to your endpoints.
Denial of wallet. I haven't heard that one, but it's terrifyingly accurate for modern serverless setups. But let's talk about workflow delegation. Daniel mentioned that one entry point might trigger subflows. How does Kong facilitate that better than just doing it inside the automation tool itself?
This is where it gets into systems engineering territory. When you decouple ingress, you can implement the router pattern. You have one ingress workflow in your automation tool that receives the traffic from Kong. This workflow doesn't do any business logic. Its only job is to look at the data and say, okay, this is a high priority support ticket, send it to the urgent response subworkflow, or this is just a marketing lead, send it to the lead nurture subworkflow.
And because Kong handled the auth and the rate limiting, that ingress workflow is lean. It's just a traffic cop. But why not just have Kong send the traffic directly to the sub workflow? Why the middleman?
You absolutely can have Kong send it directly. That's the beauty of it. If you have 5 different N8N instances running in a cluster, Kong can act as the load balancer. It can see that instance A is busy and send the next webhook to instance B. If you try to do that within 8N itself, you're already using up a worker just to decide which worker should do the work. Kong does it before the work even starts.
How does Kong know if an instance is busy? Does it talk back to the automation tool to check CPU load, or is it just doing a round robin?
It can do both. Basic round robin is the default, but you can configure more advanced health checks. Kong can probe your automation nodes. If a node returns a 503 or takes too long to respond, Kong marks it as unhealthy and stops sending it traffic. This is crucial for zero downtime deployment. You can take one ADN node down for maintenance, and Kong will seamlessly divert all incoming webhooks to the other nodes. The external service sending the webhooks never sees a single failure.
I'm thinking about the downside here, though. We're adding a lot of infrastructure. You have to manage Kong, you have to manage the declarative configurations, you have to monitor the gateway. Is there a point where this is just overkill? Like, if I have 3 webhooks, do I really need Kong?
If you have 3 webhooks and you're the only one using them, maybe not. But let's look at the statistics. The 2024 Gartner report noted that 60% of enterprises using webhooks for automation experience security breaches due to misconfigured endpoints. That is a staggering number. Usually, it's because someone left a webhook wide open without even a basic API key check because they thought security through obscurity would protect them. It doesn't.
Security through obscurity is essentially just leaving your key under the doormat and hoping no one looks there. It's not a strategy. But what about the learning curve? Kong feels like a DevOps tool, and a lot of people in the automation space are no-code or low-code specialists.
There is a curve, certainly. But the shift toward platform engineering means that even low-code teams need to understand these patterns. The overhead of managing Kong, which, by the way, can be done entirely through declarative YAML files using Kong's Deca tool, is a small price to pay for knowing that your entry points are standardized. You treat your webhook infrastructure like code. You version control it. If you need to roll back a change to your routing logic, you just revert the YAML and redeploy.
I like that. Infrastructure as code for the ingress layer. It takes the magic out of webhooks and replaces it with engineering. But let's talk about the competition. If I'm already on AWS, why wouldn't I just use AWS API Gateway? Why go for Kong?
That is a valid question. AWS API Gateway is powerful, but it's also very tied to the AWS ecosystem. If you want to move to Google Cloud or run on-prem tomorrow, you're rebuilding your entire ingress logic. Kong is platform agnostic. You can run it in Docker on-prem, in Kubernetes, on a tiny VPS, or in the cloud. Also, Kong's plugin ecosystem is much more extensive for specialized automation tasks. For example, their serverless functions plugin lets you write small snippets of Lua or Go code to transform data right at the edge.
Does that mean I could technically replace some of my automation logic with these edge functions in Kong?
You could, but be careful. You don't want to recreate your whole workflow inside your gateway. I use edge functions for data normalization. For instance, if one provider sends dates in DDD, MMMM, YYYY, and another uses YYYYMMDD, you can use a tiny Lua script in Kong to normalize them all to ISO 8601 before they ever reach your workflow. That way, your workflow only has to handle one date format. It keeps the logic layer incredibly clean.
And the cost? I know AWS API Gateway can get expensive if you're hitting it with a high volume of requests, because they charge per request. I've seen bills where the gateway costs more than the actual compute.
Kong's open source model is very attractive for high volume scenarios. You aren't paying per request, you're paying for the compute to run the gateway. For a lot of businesses doing millions of webhook events a month, say a logistics company tracking thousands of packages in real time, that can lead to significant savings compared to the pay-per-request pricing of managed cloud gateways.
Let's look at a case study. I read about a SaaS company that was struggling with mailhook sprawl. They had different email addresses for support, sales, billing, and technical alerts, each triggering a different workflow. Every time they changed an email provider or updated their CRM logic, they had to rebuild the whole chain.
That is the classic sprawl problem. What they did was put Kong in front of their mailhook receiving service. They created one unified endpoint for all incoming mailhooks. Kong would verify the signature from the mail provider, identify the to address, and then use a header-based routing logic to send the data to the correct sub-workflow.
Did it actually save them time? Or did they just move the work to Kong?
They reduced their endpoint sprawl by 70%. Instead of 50 different endpoints to monitor, they had one. When they decided to move their support logic from a legacy system to a modern AI-driven flow, they didn't have to touch the email provider settings at all. They just updated the routing rule in Kong to point the support traffic to the new workflow endpoint. It turned a week-long migration into a 10-minute config change.
That is a massive win for agility. It's about being able to pivot without having to rewire the entire building. But let's dig into the reliability aspect. If Kong goes down, everything goes down, right? You've created a single point of failure.
Technically, yes, but Kong is designed for high availability. You run multiple instances behind a load balancer. Because Kong is stateless, it pulls its configuration from a database or a YAML file. You can scale it horizontally almost infinitely. In fact, it's much easier to make Kong highly available than it is to make a complex automation platform highly available. If one Kong node dies, the others just pick up the slack.
Speaking of failure, what happens if the automation tool is up, but it's just slow? Does Kong just keep piling up requests until everything explodes?
That's where request buffering and queuing come in. While Kong itself isn't a message broker like RabbitMQ, it can be paired with one. Or, more simply, you can use Kong's rate limiting to shape the traffic. If you know your ADN instance can only handle 50 concurrent workflows, you set a concurrency limit in Kong. Any requests beyond that get a 429 too many requests response. This sounds bad, but most professional webhook senders like Stripe will see that 429 and automatically retry with exponential backoff. You're essentially using the sender's infrastructure to queue your messages for you.
That is a brilliant use of the HTTP spec. You're telling the sender, I'm busy. Hold on to that for a minute and try again. It saves you from having to build a massive internal queue.
It's about being a good citizen of the internet. You don't just crash, you communicate your state.
What about observability? If I have one giant entry point, how do I know which webhooks are failing? Does Kong give me that visibility? Or am I just looking at a big black box of traffic?
This is actually one of Kong's strongest points. It has built-in logging plugins for everything. Prometheus, Datadog, ELK Stack. You can see exactly which service or route is throwing 500 errors. You can see the latency for each specific integration. If Shopify starts responding slowly, you'll see it in your Kong dashboard before your users even notice. You can even set up circuit breaking, where Kong automatically stops sending traffic to a failing workflow so the rest of your system stays healthy.
Circuit breaking in an automation context? That's fascinating. So if my database is down and my save to DB workflow is failing, Kong can just stop the webhooks at the door and maybe even return a 53 so the sender knows to try again later.
It prevents the thundering herd problem where a failing system gets buried under a mountain of retries. Kong manages the queue at the front door. Imagine your database is having a hiccup. Without a circuit breaker, 1,000 webhooks might hit your workflow, all of them failing and retrying simultaneously, making it impossible for the database to ever recover. Kong cuts the power to that specific route, giving your database room to breathe.
I'm sold on the architecture, but I can hear the listeners thinking, okay, this sounds great for a Fortune 500 company, but I'm a small team. How do I start?
My advice is always to start small. Don't try to move everything to Kong on day one. Pick your most high volume or most critical webhook, usually Stripe or a major CRM integration. Deploy Kong in a Docker container. You can literally do this in 10 minutes. Set up a basic key auth plugin to secure the endpoint and route it to your existing workflow.
Once you see how much cleaner it is to have Kong handling the bouncer duties, you'll never want to go back to the old way. It's like getting a dishwasher after years of doing everything by hand.
It really is. And once you have that first endpoint in Kong, you can start using declarative configuration. Use a YAML file to define your services and routes. This means your infrastructure is documented by default. No more wondering where does this webhook go, because it's right there in the config file.
I also think the standard Webhooks plugin is a game changer for smaller teams. They don't have the time to become experts in every single provider's security implementation. If Kong can handle that verification out of the box, that's a huge reduction in the footgun potential.
It's all about reducing the cognitive load on the developer. You want to spend your time building the logic that actually helps your business, not fighting with HMAC signatures or worrying about whether your webhook endpoint is going to survive a Black Friday traffic spike.
Speaking of future-proofing, where do you see this going? As AI starts to take over more of the building part of automation, do gateways become even more important?
I think gateways become the control plane for the entire automated ecosystem. Imagine an AI agent that can look at your Kong logs, see that a specific webhook is throwing a lot of errors, and automatically spin up a self-healing sub-workflow to investigate and fix the issue. Or an AI that suggests new rate-limiting rules based on emerging traffic patterns.
So the gateway isn't just a bouncer, it becomes the sensory system for the whole business. It sees everything coming in and can react in real time before the brain of the automation even has to get involved.
That is the goal. We're moving from scripting to systems engineering, and that's a necessary shift if we're going to build the kind of complex, reliable business solutions that the next few years are going to demand.
It's funny, we started this show talking about simple if this then that style automations, and now we're talking about high concurrency API gateways and decoupled ingress architecture. The weird prompts are getting a lot more sophisticated.
They really are, and I love it. It shows that people are actually using these tools to run real businesses. They're running into real-world scaling problems and looking for real-world engineering solutions. Kong and Nathan together are a formidable stack for that.
So, for the listeners who are ready to take the plunge, what's the one thing they should do this afternoon?
Audit your webhooks. Go into your automation tool, count how many unique webhook endpoints you have, and check how many of them actually have robust authentication. If the answer to the first is many, and the answer to the second is few, you have a problem that Kong can solve.
And don't be intimidated by the API gateway label. At its heart, it's just a tool to make your life easier and your systems more secure. It's the bouncer you've always needed for your automation party.
And trust me, your automation server will thank you for not making it deal with the rowdy crowd at the door.
Well, I think we've thoroughly deconstructed the webhook sprawl. It's clear that as business solutions scale, we have to stop thinking about webhooks as just trigger nodes and start treating them as critical infrastructure that needs its own management layer.
Decoupling ingress from logic isn't just a nice to have, it's a prerequisite for professional grade automation. Whether you use Kong or another gateway, the principle of moving those concerns to the edge is what matters.
One last thing before we wrap up. What about the mailhook transformation? We touched on it, but how specific can Kong get with the parsing? Can it handle multi-part form data from an email?
It can. Using the Request Transformer Pro plugin or a custom Lua script, you can actually parse multi-part data, extract specific form fields, and re-encode them as a clean JSON object. This means your automation never has to deal with the complexities of MIME types or boundary markers. It just gets a flat JSON object with from, subject T, body, and attachment URL so.
Wait, so I could potentially stop using expensive third-party email parsers if I configure Kong correctly?
For a lot of use cases, yes. If the email structure is relatively consistent, like a notification from a legacy system, Kong can extract the data you need and hand it to your workflow on a silver platter. It turns unstructured email into structured API request at the very edge of your network.
That is a huge relief. I've seen some N8N workflows that are 50 nodes long just to parse a single email. Moving that to the gateway makes the workflow itself so much more readable.
Readable and maintainable. That's the name of the game. When you look at a workflow, you want to see the business process, not the plumbing. Kong handles the plumbing so your workflows can focus on the business.
Well said, Herman Poppleberry. This has been a deep dive that I think will save a lot of people from those 2 in the morning. Why is the server down? Phone calls.
That is the hope. It's all about building systems that let you sleep through the night.
Amen to that. Big thanks to our producer Hilbert Flumingtop for keeping us on track. And a huge thank you to Modal for providing the GPU credits that power this show. If you're looking for serverless GPU compute that scales as fast as your Kong-managed webhooks, check them out.
This has been My Weird Prompts. We love exploring these deeper architectural shifts with you all.
If you're enjoying the show, a quick review on your podcast app really helps us reach more people who are trying to solve these exact same problems. You can find us at myweirdprompts.com for the full archive and all the ways to subscribe.
Thanks for listening, and we'll see you in the next one.
Keep your logic decoupled and your headers secure. Catch you later. This episode was produced using Google Gemini 3 Flash. Text-to-speech by Chatterbox.
Thanks for listening to our show.